Yeah, you have 20 minutes for a nice presentation.
Thank you. Good morning. So this is my outlines of my presentation. First of all, I will focus on the mineral oil in paper-based food packaging. Then I will continue on mineral oil in the foodstuff. Then I will present the currently available technologies, and then I will describe a new technology, lastly patented, and then a future perspective. Sorry for my voice, because I used it too much yesterday. So, what's the problem of the mineral oil hydrocarbons? The problem is due to the presence of this mixture of contaminants in food. The reason why these molecules are in food is because they migrate from the cellulose-based packaging to food by a volatile volatilization, and these solvents are used just to transfer the pigments on the cellulose-based packaging. So at the end, consumers can find a quite high concentration of mineral oils in the foodstuff. For example, cereals, breakfast cereals, or eggs, or egg pasta. And so we have a health problem. The first issue to be solved with these emerging contaminants was of analytical type, because when you have to measure a mixture of thousands of compounds, it's a problem to find out the best detector or the best analytical solution. So a few years ago, I worked with GROB, which is one of the most valuable analytics in this field, and he developed an instrument based on a coupled HPLC and ZC chromatography, equipped with a feed detector, able to measure hydrocarbons very, let's say, easily. In fact, the feed detector has the ability to have the same response respect to the for the high number of hydrocarbons. So one of the health problems related to the mineral oil is due to the mineral oil aromatic component, which is considered possibly carcinogenic. The reason why EFSA uses this possibly carcinogenic adjective is because it is quite difficult to define the toxicity of a mixture of molecules. So the first problem related to mineral oil in foodstuff and in the packaging was the analytical definition, the analytical method. Then we had to define the way these molecules can migrate to food. And for this reason, different experiments were conducted at different temperatures, and it was possible to see that the usually adopted accelerated migration test can move a different fraction of hydrocarbons. So it's not so straightforward to adopt an accelerated test to define what happened at, for example, room temperature. What we can find today on the market to limit the migration of mineral oil to foodstuff is are multi-layer material. We can find this material formed by virgin paper, for example, on the external surface, recycled fiber, usually in the internal part. Sometimes you can have an aluminum foil placed on the internal part. Aluminum foil is, aluminum is considered a very good barrier for contaminants. Then we can have a plastic layer containing the food or inserted in the multi-layer. And in the last period, a multi-layer material has been developed containing an activated carbon layer inside. So this last technology is quite good to contain the migration of mineral oil from the packaging to the food, but still it is not able to remove mineral oil from the recycled paper or from the packaging. So during our study, we realized that tissue, so paper not containing minerals like carbonate or kaolin, usually added to the cardboard to give strength to the material. So in tissue, even if you start from a recycled paper, you find a very low amount of mineral oil. So the idea was to use a sorbent phase like the kaolin and the calcium carbonate that after its removal from paper to produce tissue could remove mineral oil. So the idea was to synthesize or to find a very sorbent phase more affine to mineral oil to remove this pollutant from cellulose-based packaging. So we started the first experiment using an Italian newspaper well known to be highly polluted with mineral oil. And we prepared in the pulper the pulp in contact with our sorbent. So this was the idea. And, sorry, I skipped the slide. So we added in the pulper our sorbent, then the cellulose additivated with our sorbent was washed, and then it was used to form a cardboard. So we tried a different sorbent phase, and then we selected a mesoporous materials, a silica porous materials anchored with an organic, functionalized with an organic molecule, just to increase the affinity for mineral oil. The sorbent was stable to eventual thermal treatment for its subsequent recycling. So what we obtained was that the paper produced in the presence of the sorbent was able to retain mineral oil at a high level. And when we used this paper in contact with, when we put this paper in contact with food, in this case it was a flour, we could observe that the mineral oil, and in particular the saturated and the aromatic part, remained in the packaging, and just a very small amount migrated to the flour. So with these positive results, we proceed to synthesize a sorbent in form of monolith. So a monolith was synthesized just in one step, and then it was functionalized with some organic functionality. So this monolith can have, of course, a different shape. We produce it in a form of cylinder, and we add this, the idea is to add this sorbent in the head box, in the container where the cellulose has been already washed, and it's ready to be spread for forming the paperboard. So other characteristics of this sorbent material is that it can float on the water, and for this reason it is very easily recoverable. And the shape can be adapted, so we can decide which type of shape is the best for the best absorption. The surface area is quite high. We are at about 500 square meters per gram. It has a good mechanical resistance, so it can just be put into this big tank and stay in touch with water for a long time. The water, of course, is moved inside the tank. It is fully thermally regenerable, so it is possible, once the absorption is exhausted, after the absorption of mineral oil, you can recover the sorbent, treat it in an oven, and use it many times. And then it has a good affinity to hydrocarbons. So we tried we made just a few experiments with this material. And this is the last result we obtained. The absorption was conducted, the best result we obtained was at 50 centigrade degrees. And what we obtained was a paper where the content of mineral oil was 0.6 ppm. The paper produced in the absence of the sorbent was 3 orders of magnitude higher, and it was higher than 200 ppm of mineral oil. So if we consider that the limit imposed or suggested by the Germany is for mineral oil aromatic hydrocarbon is of 0.5 ppm, we are almost very close to this limit, but considering aliphatic and the aromatic fraction together. So we believe that this is the best solution to remove mineral oil from cellulose-based packaging to produce safe paperboard for food contact. So this paper has been, this patent has been deposited at Italian, at a national level, and then in July it was extended to ETC, it was under ETC extension, PCT extension, sorry. Thank you.